The question is, from point A and B at the respective heights of 2 meter and 6 meter, two bodies are thrown simultaneously towards each other. One is thrown horizontally with a velocity of 8 meter per second and other downward at an angle of 45 degree to the horizontal at an initial velocity such that bodies collide in the flight. The horizontal distance between points A and B is equal to 8 meter. Calculate. So we are supposed to find out four things. First, initial velocity v0 or the body thrown at an angle of 45 degree. Second, coordinate x comma y of the point of collision. C, time of flight t of the bodies before colliding. And finally, the velocities va and vb of the two bodies at the instant of collision. So first of all, we are going to draw the diagram. So it states that two bodies A and B are at a height of 2 and 6 meters. So let us this body A and this is body B. The height is given as 2 meters of body A, and of B it is given as 6 meters. Body A is projected horizontally with a speed of 8 meter per second, and let us suppose it travels something like this, and body B is thrown at an angle of 45 degree with the horizontal, and let's they meet at this point P. This angle is 45 degree. So let us call the coordinate of this point P as x comma y, and the distance between this object A and object B is given as 8 meters. So this is 8. So let us define some things here. Let us call this horizontal distance of object A when it collide with object B as x, and vertical distance as y1, and let us call this distance for object B as x1, and the vertical distance traveled by object B at the point of collision, let us call this as y2. So obviously this will be y, and let us call this as origin. So first of all, let us consider the horizontal direction. So first is body A. So the horizontal distance traveled by body A in time t, where t is the time of flight from both objects from A as well as B up till the collision point, that is P. So we can say that horizontal distance x will be equal to horizontal velocity multiplied by time t, and horizontal velocity is given as 8, so we can say that x is equal to 8 times t. Similarly, we can write for body B. We can say that we can divide this component into two parts. This will be, and it is launched at a velocity v0, so this will be v0 x, and this component will be v0 y. So we are going to get v0 x is equal to V naught cos of 45, that is equal to V naught divided by square root 2. V naught y will be equal to cos sine of 45 is equal to V naught square root of 2. And from the figure we can also say that x plus x1 is equal to 8. Y will be equal to 6 minus y2, and y can also be written as 2 minus y1. So these equations we are going to use later on also. So we can say that for body B, the distance x can be written as x is equal to V naught cos 45 multiplied by time t. So this x1 will be equal to V naught square root 2 multiplied by time t. So we have already said that x plus x1 is equal to 8. So we are going to use this formula here. X plus x1 is equal to 8. We are substituting value of x as well as x1. So x is equal to 8t and x1 is equal to V naught divided by square root of t, square root of 2 multiplied by t. So you put x equal to 8t plus x1 is V naught divided by square root t is equal to 8. So from here, if you take t common, so we can write this as 8 plus V naught square root 2 is equal to 8. Now in vertical direction, for body A, we get SYA will be equal to UYA multiplied by T plus 1/2 AYA multiplied by T square. Okay, so for the body A, we already know that SYA will be equal to body A, SYA is equal to minus of y1, and there is no vertical velocity, only horizontal velocity is present, so UYA will be equal to 0, and okay, so we can substitute one thing left, that is AYA will be equal to minus g. So we can say that minus of y1 is equal to, so this will be 0, so we are going to get minus half g t square. So we can say that y1 is equal to 1 by 2 gt square. And we also know that y is equal to 2 minus y1. So if you find out here y is equal to 2 minus y1, so it will be 1/2 gt square. This will be our value of y for body A. Similarly, for body B, we can write it as S by B is equal to U by B multiplied by T plus half A by B T square. So we can get this as Y2 is equal to V0 square root T minus 1/2 G square root. So we already found out that Y is equal to 6 minus Y2. So from here we can find out Y is equal to 6 minus V0 square root T minus 1/2 Gt square. So we have two equations of Y. This is, let us suppose, equation number 2, and let us call this as equation number 1. So equating equation 1 and 2, we are going to get equation 1 and 2. So we are going to get this as 2 plus half Gt square is equal to 6 minus V0 square root 2 T plus half Gt square. Gt square goes out with this. So we are left with V0 T 2 is equal to 4. So from here we can say that T is equal to 4 multiplied by square root 2 divided by V0. And we already found out this equation. We are going to use this part as well. So we already know that 8 is equal to 8 plus V0 square to T. So in this equation we are putting the value of T. So this will be equal to 8 plus V0 square root 2 multiplied by 4 divided by V0. This will be equal to 32 divided by V0 plus V0 2 multiplied by 4 2 divided by V0. So V0 cancels, 2 and 2 goes, square root of 2 and square root 2 goes. So we are left with 8 is equal to 32 square root 2 divided by V0 plus 4. From here we can write that 32 square root 2 divided by V0 is equal to 4, or V0 is equal to 8 square root 2, and this will be coming as 11.313 meter per second. This is the value of initial velocity V0 of object of body B. So next we are going to find out. So from, we already know the relationship between T and V0. So T is equal to 4 root 2 divided by V0. Substituting the value of V0, V0 was 8 root 2. So this will be equal to 1 by 2. So time will be equal to 0.5 seconds. Next we are going to find out two coordinates. So coordinate x we already know is given by 8 multiplied by t. So this will be 8 multiplied by 0.5. So we are going to get this as 4 meter, and y is equal to 2 minus half into 9.8 0.5 square. So this will be equal to coming as 0.775 meter. So we can say that point P, whose coordinate given by x, y, will be represented as 4, 0.775. Okay, now we are going to find out the velocities at point P just before the collision. So velocity at P just before collision. So for body A, let's call it the velocity VA, which will be equal to x component square plus its y component square. Now we know that in the horizontal direction, the entire journey, the velocity remains same. So we can say that VAX will be also equal to 8 meter per second, and VAY we can find out by using the formula UAY plus AAY multiplied by T. Now there is no initial velocity in the y direction, so we can write this as this will be 0. This will be coming as minus 9.8 multiplied by time we calculated already for 5 seconds. So VAY will be equal to minus 4.9 meter per second. So substituting the value of VAY and VAX in this equation, so we get VA is equal to 8 square plus minus 4.9 square root, and VA can be written as 9.4 meter per second. Similarly, we can do for body B. For body B, we can write VB is equal to VBX square plus VBY square and its square root. VBX is equal to Vx, and which was equal to V0 2, and V0 we already know is given as 8 square root 2 divided by, so this will equal to 8. Okay, this will be minus and this will be minus. Similarly, VBY is equal to UBY plus ABY multiplied by T. This will be equal to minus V0 2, and this will be minus GT. So we can solve it further by like this. VBY substituting the value, V0 we already know is given by square root 8 square root 2, so this will be coming as minus 8. This will be 9.8 multiplied by time, that is 0.5. So you can write that this will be equal to minus 12.9 meter per second. So we know VBX as well as VBY. So velocity VB will be equal to minus 8 square plus minus 12.9 square root, and VB can be finally written as 15.2 meter per second. So these are the VA as well as VB, that is velocity at point P, that is collision point. So in this question we were supposed to find out 4 things: initial velocity, coordinate, time of flight, and velocity before collision. Thank you.